All right, so this is just a little bit of practice with numbers and putting them into scientific notation, and then we'll try taking a couple numbers out of scientific notation as well. So the first number we have here is 3 million. So we know when we write something in scientific notation, we have some leading digit, and it has to be multiplied by a power of 10. Now, this leading digit that goes in front, it has to be greater than 1, but less than 10. So in between 1 and 10. So what we want to do is if we look at this number, our 3 million here, we know if we were to put a decimal on it, the decimal would happen at the end. Okay? So we want to move this decimal back until we get a leading digit that is greater than 1, but less than 10. All right, so see if I put my decimal right here, that wouldn't work because I would have 300. So we've got to keep going. Would it work here? Nope, we have 30. What about here? Oh, yes, that does work because that gives us 3, which is greater than 1 and less than 10. So that's what we put for our leading digit, and then we multiply by a power of 10. But 10 to what power? How do we know? So we know by counting how many times we had to move the decimal. So it's going to be 1, 2, 3, 4, 5, 6. So we would have 3 times 10 to the 6th. All right, the next one. Now you can try this on your own if you want. And then compare it to the work that I do and see if you get the same answer. Now this one, we have a small number here. We have just a decimal here. So again, we want to move this decimal, but this time we are going to be moving to the right because we still want to have a leading digit between 1 and 10, and it's going to be multiplied by a power of 10. Now, we don't know what power of 10 yet. So let's move that decimal until we get it in between numbers that give us a number that is greater than 1, less than 10. So what if we stopped it right here? That would give us 4.67. Well, it's greater than 1 and it's less than 10, so we're good. Now we want to make sure with that leading digit that we include that 6, that 6 and 7 as well. So it is 4.67. All right, here's the thing with this one. When we move the decimal to the right, and in this case we moved it 1, 2, 3, 4, 5. Oh, we moved it 6 places here as well. Now here's the difference. When we move the decimal to the right, we get a negative exponent. So it's 10 to the negative 6. Now, in the first one, we moved our decimal to the left. So if we move the decimal to the right, that gives us a negative exponent. And if we move our decimal to the left, that gives us a positive exponent. And another way you can tell, so sometimes the way I think of this is I can tell if it gives us a little teeny tiny number, like it does here. So if it gives us a number that's less than 1, there's going to be a negative exponent. And then if it gives us a really large number like here, that's going to give us a positive exponent. All right, so if you got those, great job. Now we're going to take some numbers and scientific notation and put them into not scientific notation, which is known as standard form. So let's try, say, let's say we have 3.05 times 10 to the 8th. All right, so we've got to work backwards to take this out of scientific notation and put it into standard form. So what we want to do is start by looking at this leading digit. We'll copy that down, 3.05. And we want to move that decimal 8 places. We're going to move it 8 places to the right. So it's kind of opposite when we're taking it out of scientific notation. So again, a positive exponent means we're going to have a really big number. A negative exponent means it's going to be a small number that's less than 1. So let's take it and move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So this is where our new decimal is going to land. All right, now we have these, you can see that we have these empty valleys, you could call them. Those we want to fill in with zeros. So let's go ahead and do that. All right. Now I'm going to erase my original, So I erased my original decimal and I moved that new one 8 places to the right. All right, now, so to make this number more readable, we do want to put in commas. And remember, from the decimal, we put a comma, if we're going backwards, every 3. So I'm going to put one here and put one here. So here we have 305 million. All right, let's try that one more time, but with a negative exponent. And again, what you can do is you can try this on your own and then pause the video and then compare your answer to my answer. So let's say we have 6.80 2 times 10, we'll say to the negative 4th. All right, so again, that first step is going to be taking a look at our leading digit. We'll copy it down. So 6.802. All right, so we've got our leading digit. Now, this is being multiplied by a 10 to the negative 4th power. So the negative 4th, any negative power tells us that it is going to be a number that's less than 0, which means we have to move the decimal to the left. So there's 1, 2, 3, 4 places. All right, so that's where I'll put my decimal. Now remember, we've got these empty little valleys here that we want to fill in with zeros. All right, I'm going to erase these in my original, and then just to make it a little bit neater here, it looks like my new number is 0.0006802. All right, so that's a little bit of extra practice, and that's all for this one.